Good morning, friends. Welcome back to my channel, Coding Environment. Today, we are going to learn something about queue data structure. If you are a fresher or looking for a job in IT industry, you may get a question in interview on queue data structure, or the interviewer can say you to write your own program for queue data structure. So, to write your own program of the queue data structure, first you have to know how that queue data structure works. It is a common data structure which has been used in all the programming languages like C, Java, Python, or you can take any programming language. It is used in all of the programming languages, and it is a very popular and very useful data structure which is generally used in most of the programs. So let's see what is queue data structure in detail. So what is queue, or what is a queue data structure used in programming languages? If I go with the definition, queue is a linear data structure in which the addition and the deletion of the elements happen at the opposite ends. Or we can say that the elements which is inserting at first will also get removed first. It's also called first in first out or last in last out, which is commonly known as FIFO or LILO. The property of this queue data structure is that insertion and deletion of the elements happens at the opposite end. If you ask me, I can think of the best example of that queue data structure is a queue of people generally standing in a bus stand or a railway station queue. So if you see this lady who is standing in front of this queue, this lady must have come at the first in this queue, and this is the person who is in the second position, and this is the lady again in the third position. So in this queue, this lady will always get her work done first, or you can say this is the lady which can leave this queue at first. So person who is coming into this queue at first will get deleted from that queue at first. It means that first in, this lady first in and first out. Similarly, we can say last in, last out. So the person who is in this green shirt has moved into this queue at the last, and this element, or you can say this person, will get processed at the last in this queue. So this is all about the queue data structure. So let me demonstrate how the elements are getting inserted and deleted in a queue data structure. So suppose I have an array from index 0 to index 4. I will say why I am using this fifth element also, but I will explain later why I am using this fifth index also. So just assume that I have to insert 5 elements in a queue. Now in this queue I have to maintain 2 positions, or you can say in this queue I have to maintain 2 indexes. One will represent this first element in the queue, and the other one will represent the last element in the queue. So if you see this particular queue, one index will represent this one and the other index will be representing this one. So I have to create 2 indexes for the queue. So one is the front, which is this front one will represent this index, and the rear will represent this index. Now let's insert one element into this queue. Suppose I am inserting 10 at the position 0 in that array. Now once I move one element at the position 0, I have to move this rear to the position 1, so that when I am inserting my next element, it will get inserted at the rear position. Again, if I am going to insert one element into the queue 25, I have to move this rear to the next position. Similarly, again, if I am going to add one element 15, I will move this rear to the next position. So you see, the moment if I am adding one element into this array or into this queue, I am moving this rear index to the next position, but my front element is still pointing to my first element into that queue. Now again, let me put some more element into this queue, and now suppose this is the last element I put into this queue. So my rear will be representing this fifth index in the array. So this is the way we are inserting one element into the queue. We have to keep this front to the first element in that array, and the rear will keep on moving and keep index of the last element inserted into the queue. So what are the operations mostly performed on this queue data structure? There are mostly 4 operations performed in this queue data structure. One is enqueue, the second one is dequeue, the front, and the display. So enqueue is the operation of inserting an element into the queue. Similarly, dequeue is the operation to delete one element from the queue. Front is the method which will return the first element into the queue, and display will display all the elements into the queue. So let's see all this method one by one and try to understand how this queue can be implemented in Java. So just like stack data structure, we can create this queue data structure again using an array. We can create it using the linked list also, but for the sake of simplicity, I am going to create it using an array. Again, we have to initialize this queue data structure using the array and saying what is the capacity of this queue. And again, we have to initialize the rear and the front variable which will represent the different value of the index in this queue. So suppose if we are going to create a queue with the capacity 5, we have to pass here int c as a 5, and that will get set to the capacity, and the array will get created with the capacity 5. You have seen that this front and the rear indexes are set to 0. So this is the initialization of that queue data structure. Now the one method which we have to create is the enqueue or the queue enqueue method. This method is used to insert one element into the queue. Now suppose if I am going to insert one element 10 into this queue, I have to pass 10 here. So before inserting anything into the queue, we have to see that is our queue is empty or full. So how we can check that the queue is full or not? If my capacity and the rear value is same, it will say that the queue is full. So suppose this rear is representing this 5, and how many elements we can insert into this queue? It is equal to 5 only, right? And this rear is also representing the 5. So in this condition, we can say that our queue is full. If rear is pointing to 4 or if rear is pointing to 3, it means that there is one place or two places still left into the queue so that we can insert one element. Now, if the queue is not full, it will go into that else condition and put the data which we want to insert into the queue at the rear index. Suppose if there is no element into the queue, the rear and the front will pointing to the same index at the 0 index. So if it will come as a 10 here, what will happen? 10 will get inserted at this position, and with this rear plus plus, rear will move to the position 1. Now suppose again if you want to insert 25, it will see that the capacity and the rear is having the same value or not. So here if you see, the rear value will be 1 and the capacity value is 5, which is not equal. So the control will move to the next line, which is inserting that element into that position 2. So with this queue rear equal to data, we are going to put this 25 into the index 1 and then again move this rear to the next index. So similarly, it will keep on moving this rear index to the left side and then keep on inserting the data unless and until that queue is full or not. Now let's see how we can create the queue dequeue method, which is the method used to delete one element from the queue. So you have seen that the insertion of the element is happened through this rear index, but the deletion of the element will happen through the other index, which is the front index. Now again, before deleting any element from the queue, we have to see that is there any element actually present in the queue or not, or is the queue is empty or not. So if my front and my rear position is pointing to the same value, it means that there is no element inserted into this queue. So if my front and rear is equal to same, it will print that queue is empty and it will return because there is no element has to be deleted from the queue because the queue is empty. Now suppose this condition is not fulfilled. It means my front is pointing to some other index and the rear is pointing to some other index, which represents that there are some elements present into this queue. So if this is the condition, now suppose if I have to delete this 10 from this queue. So how I can do this? So to delete this 10, what we have to do is move this 25 from index 1 to index 0. Then again move this 15 from index 2 to index 1. Move this 28 from index 3 to 2. And move this 35 from index 4 to 3. So basically we are keep on moving all the subsequent values from its left index. Then move this rear from index 5 to index 4. So to do this, what we have to do is we can use a for loop where it will initialize from this index. So I equal to 0, I is rear minus 1. So it will go till this point, right? Because we have to move this 35. So rear minus 1 will represent this particular index. So what we have to do is qi equal to qi plus 1. So it is going to put this 25 at the qi position, which is the index 0. So 25 will get moved to the index 10. And similarly, in the next for loop, it will move 15 from index 2 to index 1. So it will keep on moving all these values to this position, and at last, and it will decrement the rear value from 5 to 4. So this particular statement is going to decrement the rear value also. And there is one more condition which we have to verify here is if rear is less than capacity, q rear equal to 0. Why we are doing this particular operation? Now, because we are deleting this element 10 from this 0th index, all this element is getting moved from here to here and here. But you see this 35, actually when you override this 28 with 35, this index will still set to 35. We have to set this index to 0, or we have to reset this index so that it will not look like that the value after deleting the 10 will be 10, 25, 15, 28 and 35. See, this value has to get reset once this value is moved from position 4 to position 3. So to do this, we are doing this particular operation. So this is all about enqueue and dequeue, or inserting and deleting an element from the queue. Now let's see how we can display this full element, or how we can display all the element from the queue. So if my front and rear equal to 0, there is no element in the index. This condition we have already seen while performing the dequeue method. Else, if this condition is not satisfied, we can go and traverse this full index and print value one by one. So to traverse this, we can use a for loop saying that I is equal to front, which is this index, and if I is less than rear, which is this position. So if there is 5 element in this index, my front will presenting 0 and the rear will represent this 5th number. So if it is the case, then if I equal to front, I is less than rear, I plus plus, and it will keep on printing this q and I. So first time it will print 10, then print 25, print 15, print 28 and print 35. So this way we are going to display all the elements from the queue. Then we have a method which will give the first element into the queue. So in this case also we are going to see that is there any element actually present in the queue or not. So to do that, we are going to check the same condition, that if front is equal to rear or not. If this is the same, then we are going to say that queue is empty. And if it is not, we can just give that value of queue front, because front will always keep the value at the front position. Now, this is all about 4 different methods which we generally perform on a queue data structure. So now let's move to Eclipse and run this program. So let's run this program in Eclipse. So for the sake of the time, I have already written this QDemo class in Eclipse, and I can show you all these methods which I have explained in the PowerPoint and show how these methods are getting executed in Eclipse. So as I showed, we have to first initialize that queue data structure. So just like front is equal to, so we have to initialize first these 2 indexes and then the capacity, and we have to create actually one integer array with the capacity which is provided in this argument. Now the second method which we are going to do is the queue in queue. In this, we are going to insert the elements into that queue data structure. If we are going to pass any element into this method, it will go and insert that element into that data structure. Suppose if you are passing 10 here, it will go and see is that queue is full or not. If it is not full, it will put the data at the rear position and then increment that rear index value. So with this dequeue method, we are going to delete the element which is represented by the front index. So to delete that element, basically we are going to override the element by its next index and keep on shifting all the elements from the left index to the front index. So this for loop is used to shift or override the value which is at the front index. Now again we have one method, queue display, which will be used to display all the elements into the queue. It will just again check that the queue is empty or not, and if it is not empty, it will traverse the queue and display all the elements from the queue. Similarly, this queue front will give you the element which is at the front index of the queue. So now let's run this program quickly and see what the output is coming. I have a driver method here which is going to basically initialize our queue with the capacity 4. It means we can at max insert only 4 elements into the queue. Now once this is done, we are going to display the queue. Because we have not inserted any element into the queue, this will say that the queue is empty. After that, we are going to insert 4 elements into the queue. Because the queue capacity is 4, all these 4 operations will get successful and we will be able to insert all this element into the queue. Now once this is done, we can display all the elements from the queue using that queue display method. Now after that, if you are going to insert again any element, it will say that the queue is full and it will return. Because that queue capacity is only 4, this operation will not be successful. After that, again it will print this queue. Now we can do this dequeue operation also. So if I'm doing 2 times dequeue, it will delete these 20 and 30 elements from the queue because these 2 elements we have inserted at the first. So after deleting, it will print whatever the elements left into that queue. So after this will print only 40 and 50 because these 2 elements are only left into the queue. And after this, we can get the element which is at the front position. Can you guess which is the element at the first position? It is the 40th element because we have deleted this 30 and 20, and after this will be the element which will be at the front position. So let me run this program and show this output once. So see here, if I have created a queue with a capacity 4 and I am displaying this queue because we have not inserted any element into the queue, the output is saying that the queue is empty. After that, we are inserting 4 elements. So it is displaying all these 4 elements. This 20 is at the first position and this 50 is at the last position. After that, if you are trying to insert this 60, it is saying that the queue is full. Once that the queue is full, we are going and deleting 2 elements from the queue. So after deleting 2 nodes, you can see this first 20 and 30 element got deleted. And now we have only 40 and 50 element into that queue. And this queue.front is returning 40, which is the first element into the queue. So this way we are going to create the queue using array in Java. So let me run this program into that debug mode and show all these operations in slow motion. So let me initialize it. Let me put a debugger into that enqueue operation and one into the dequeue operation also. And display queue, and these are straightforward, so I'm not going to put any debug pointer into that. So let's run this program into the debug mode and see how these operations are getting executed in debug mode. So okay, I ran it. Actually, I have to debug as Java application. Okay. Once we initialize that queue data structure, see this front and the front value is initialized with 0. This rear value is also initialized with 0, and the capacity which we have passed as a 4. So you can see that this capacity is also initialized with 4. And now we have initialized this queue data structure also, saying that there is 4 element into the queue and all the 4 element is right now showing it 0, 0, 0 because that 0 is the default value for any integer. Now let's insert one element into this queue. So once we are going to insert one element, suppose 20 we are going to insert here, it is going and checking that the capacity and the rear is same or not. It is basically checking that the queue is full or not. So because this is the first element we are inserting into the queue, that this capacity is 4 and the rear is representing the position 0. So this is not same, it will go into that else, and this data which is 20 we are going to put into this queue. Now once we execute this particular line, you see this in this queue the 0th index is overridden with the 20th value, which is the value which we wanted to insert into the queue. Now once this operation is done, this rear we have to move to the next position. So with this rear plus plus we move to the index 1. Now our front is pointing to the index 0 and the rear is pointing to the index 1. If you want to see, you can see it here. See, this front is pointing to the 0 and the rear is pointing to the 1. With this we can see that our data got inserted into the queue. So you can see it here, the first data got inserted into the queue. Now again if you want to put 30, it will go and check the same condition because this capacity is again 4 and rear is 1. This condition is not satisfying and again this value is getting inserted into the queue. So all this operation after completing all this in queue operation, we can see that this queue is full. This 20, 30, 40, 50 we have already inserted into the queue and my rear is still pointing to the 4. Now if you are doing this display, it will display all this element here. Now you can see it displayed all the element. Now suppose if I want to insert again one more element into this queue, it will go and try to insert it. Now this capacity is again 4 and my rear is also pointing to the 4. So it is saying basically that your queue is full. You have 4 element into the queue and the capacity is also the 4. So this condition will get executed and it will say that queue is full. So it is saying queue is full and it will return from this method. Now again if you see, it is going to display all the elements here. Now we want to delete some element from the queue. So this first line it is going and trying to delete it. Now if you see this front and rear saying that the queue is empty or not. No, because the front is pointing still to the 0 and the rear is pointing to the 4. So this condition will not get satisfied and it will move to the next position. So what we have to do into the queue dequeue operation, basically we have to move all the elements from the front plus 1 position to the front position. So see here, what we are going to do is we are actually moving this from the 0th index to the next index. So see here, I is pointing from 0, so it moved the value of index 1 to the value of index 0. So with this operation, suppose if you see here, this queue value is 20, 30, 40 and 50. After executing this particular line, what is this queue structure now? See, this 20 got overwritten with 30. Now in this 20 got overwritten with 30 and still this 30 is there. So in the next execution, this 40 will override the 30 and the 50 will override the 40. At the last, we have to override this 50 with 0. So let me execute one by one and we can see it in one shot. So see here, this queue 40 got this 30 got overridden with 40. Now again if you see here, this 40 got overridden with 50 and this operation got over. So now at this time, if you see, my first element which was the 20 got deleted, but there is one 50, but there is one element 50 which is at the position 4. This we have to override with 0. This we are doing into this particular block. So you can see it here, your rear position now moved to 3. Now similarly, if you want to dequeue here, it will go and do that operation and it will dequeue it and rear will pointing to your 3. So here it will go, and then after 2 nodes deletion, it will print that value, which is 40 and 50. And this is all about that Q data structure. So hope you liked this video. If you liked it, please subscribe to my channel and stay connected. For timing, have a great day and goodbye.